Hello everybody and welcome to another mystery box function challenge. In the purple mystery box there is some math and your challenge is to figure out what it is. Today is not a Friday, so you might be wondering, why do we have a challenge, a special challenge label on our mystery box? Well, we are coming to the end of this series. This is the last week. I made a commitment to do one of these every day for an entire year, and next week, Tuesday, will be 365 days. So I thought we'd put more or less challenging ones in for the last 7. So today's is going to be a little more challenging than usual. Hope you enjoy. And let's get started. I'm going to put in a 0. So 0 gives that infinity error. So I'm thinking rational function to begin with. Let's put in a few more points. How about a 1? All right, 1 gives us 2. How about a 2? That's 2.5. How about a 3? It's 3 1/3. Okay. Let's do 4. Well, that's interesting. 4 1/4. I'm going to try to get a little closer to our what I think is an asymptote. Let's do 1/2. Oh, and now it's going up there. Okay, and let's do 1/4. Okay, and let's check in the negatives. How about negative 1/2? And negative 1. And negative 2. Okay, we're getting symmetry here. All right, so you can see this shape. We've got an asymptote, a vertical asymptote at 0, and then we've got a slant asymptote here. And there are a couple of ways to figure this one out. When you have a slant asymptote, that maybe means that you've got the bigger power on top, and you have to divide. And when you divide what's on the top by what's on the bottom, then what's left, your result is going to be an equation for the slant. And it looks like we've just got y equals x as our slanted line, or y equals x plus 1 as our slanted line. But I noticed something else going on in here that just jumped out right away, this pattern with the numbers. So when I put in 1, I got 2. When I put in 2, I got 2 1/2. And then 3, I got 3 1/3. And 4, I got 4 1/4. So now 1 is a little different, but it looked to me like I was always getting the number and 1 over the number, the number and 1 over the number, the number and 1 over the number. So I think that's what's going on. If I put in a 5, I should get 5 1/5, so 5.2, right? Let's try that. Yeah, and there's 5.2. And this is going to work. Well, let's think about how this is going to work with a fraction, right? So if we put in 1/2, I'm going to get the number, which is 1/2, and 1 over the number, which is 2. So 2.5 again. If I put in 1/4, I'm going to get the number and 1 over the number, which is 4. So 4 1/4. And that's what I'm getting there. So I think this is basically just 1 over x plus x, or x plus 1 over x. If you want to look at this algebraically in the way you might get an equation with a slant asymptote, you could think about making the denominators the same. So what I could do is I could multiply this by x over x. So that would be 1 over x plus, and x times x on the top is x squared, and then I have the x on the bottom. Now the denominators are the same, and I can add this. I'm getting, well, I'll write the x squared first, plus 1 over x. So maybe this is the answer. Maybe this is the answer. Either one would be the same, amount to the same thing. I like this answer because that's the pattern that jumped out at me from these numbers. Well, let's take a look and see. So they wrote it as 1 over x plus x. And let's graph that as well. Yeah, and it looks very much like one of these rational functions where the numerator has the higher power than the denominator. So you get that slant asymptote. Well, how did that go for you? Did you come up with this x squared plus 1 over x, or did you notice what's going on in the numbers and come at it the way I came at it? Let me know. Thanks, everybody.